Alright, welcome, and in this unit we are talking about exponential functions. We've talked about linear functions, create a line. So now we're moving on to exponential functions, and the main part of this is the exponent part. This has the word exponent. So that means our function, our equation, is going to have an exponent in it. So let's get started. To begin off this video, we're going to start off by looking at the graph of exponential functions. So an exponential equation is one in the form of y equals a times b to the power of x. And I'll be color coding in this video, so if you want to follow along. A These are the main parts. B and x. Notice our x value, instead of being part of the equation, is actually my exponent. Again, which is where we got the word exponential from. Alright, so we're going to graph an example here on the graph. And the example we are doing is f of x, which is the same thing as y, equals 4 times 0.5 to the power of x. So the important parts here are 4, which is your a value, .5, which is your b value, and obviously the x, which is my exponent, or my input. So we are going to create a graph by making a table of values using, for the most part, just random numbers for the x values. I'll go ahead and color code this too. A good set of numbers to go with is you want to have some negatives and you want to have some positives. You want to start off with small negatives and small positives, so you don't want to get too crazy. So my go-to is -3, -2, -1, 0, 1, 2, and 3. And then it's just a matter of plugging into my equation up here to get the value that goes right there for your f of x. So for example, f of x is going to equal to 4 times 0.5 to the power of -3. And to do this, I'm going to grab my calculator. I'm just going to do this part over here. 4 times 0.5. Use the caret key to raise it to the power of -3 and get my answer, 32. And I'm going to continue to do that, either here by calculating or on your table in the calculator. I went to y equals, and I'm going to type in the equation after the equal sign, so 4 parentheses 0.5, again to the power of, not -3, but I'm going to go back to the original power of x. And then to bring up the table, I press the second button on table, and here I can scroll up and down to get the values I want. So -2 would be 16. -1 would be 8. And by now, I'm hoping you're seeing a pattern developing to where you can continue the table on your own. If not, we just keep looking here. 0 would be 4. 1 would be 2. And if you haven't picked up on the pattern yet, notice each time we are splitting the previous number in half. In other words, dividing by 2 or multiplying by 1/2 each time. 1, and then 0.5. Remember, this can also be done on Desmos. We just type in the equation. F of x equals, for again the original equation. And then the same way we did it, we raise it to the power of x, the caret key. If you can't find the caret key, down here at your keyboard, and the power button is this one right here. Then I'll bring up a table by pressing the settings button in table, and here we have it. And I wanted to do -3, -2, -1. I'm just retyping over it, and it created my table for me. Either way works. Okay, so we have my table ready, and on Desmos it created the graph for us, but we're going to go ahead and plot the graph that we have with the numbers that we got. So, alright, so let's take a second to recognize that this down here, where x is equal to 0, this is my y-intercept. And if you notice, that value of 4 is actually my a value. Therefore, we can say a, whatever a is, anytime we're in this form, is my y-intercept. I'm going to go ahead and plot that one. At 4 for my y-intercept. And I'm going to go ahead and plot the other points. So we have -3, 32, which is not on the chart. So we move on to the next one, -2, 16, -1, 8. And what you'll notice is that though it looks pretty linear right now, it will not end up being a linear graph. It's going to look exponential, which is going to look like that shape that we saw on Desmos. 0, 4, 1, 2, 2, 1, and 3.5, or 0.5. And if I were to continue this, I'm going to put those with markers so y'all can see those better. Ooh. If I were to continue this, each time, like we said, we're splitting in half. So the next would be like right here, and then right here. And you'll notice every time you're taking a number and splitting it in half, you're never going to get to 0. And that'll bring us to our next topic after I connect my points. Notice when I'm connecting, it's going to sort of flatten out, but I'm never touching the actual 0 value or the x-axis. Also notice I draw my arrows. Just like with lines, it does keep going. My pattern continues in forever unless they specifically say it doesn't. Okay? So, like I said, that brought me to my next point. Because it never touches 0, this serves as sort of a boundary line, meaning it is not going to cross over to the negative side. It is not going to touch the x-axis. It's not going to flip over or go anywhere all of a sudden decide to change. So we call this special little boundary line an asymptote, and it's an imaginary line, so I'm drawing a dashed line to show it's there but not really there. I'm drawing it right above the axis just so you can see it, but it's really the axis. Again, we call that the asymptote. And in this case, that is the 0 value, so it is where y is equal to 0. Depending on where your exponential function is located and where you see it flattening out, that's going to be your asymptote. Okay. And then one more thing I want to discuss on the graph before I allow you to move on to your own thing is notice my graph, like we talked about, for a type of function, it is a decreasing function. It is going down from left to right. It is decreasing. So we call that decay. It is a decay. And the true reason behind the decay is because if you notice B, which we haven't really mentioned much, but it is an important part, my b value is actually less than 1. So that's 0.5 is less than 1. Okay? You're going to answer a few practice problems on your own. And then you are free to move on to the next video.